So I realized I missed the bottom of this page, so versus making the whole second video, I'm just going to come down here and fill in this part. So this is the quadratic family, just like we had the linear family on the other page, and basically the quadratic family, the parent function or most simple quadratic is y equals x squared. Anything in this form is going to make the shape that's a parabola. Remember, that's the same shape we find on those conic sections. And how to tell if a function will be a parabola, basically anything that has an x squared in it. So this is called the standard form, but there are other forms. Anything that has a y equals, there can be other stuff around it, but if the highest power of x is x squared, that's going to be a parabola. So just like we said, the coordinate plane allowed us to have these algebraic formulas for slopes of lines and midpoints and distances between points. There are algebraic formulas and different processes for the geometric shape that is a parabola. So here, if I have a function in this form, basically first off, we can tell if the parabola goes up or down. Opens up kind of like a cup like you see in this picture, or if it's flipped over and down like our other example in the other page. If x squared is positive, the graph opens up, and if x squared is negative, the graph opens down. The width, the larger the value of a, the wider the graph. So basically if I have a 2x squared, that's going to make a wider parabola than a 1x squared, or 1/2 x squared. So 1x squared will kind of have more of that shape in comparison. The axis of symmetry, and if we talk about symmetry, that's definitely a geometric term, is the line that cuts a parabola in half, because a parabola is symmetric around that line. So if I take my equation and I get this, I get negative b over 2a. That's the formula. In a future lesson, we'll see like why that formula makes sense. But for now, we can also see that the axis of symmetry always has to be exactly between the roots on the parabola. So actually, if you average the roots, it will also give you the axis of symmetry. It's an x equals line because it's always, as long as we have y equals x squared, it's always a vertical line. The turning point, which is also known as the vertex, okay, that is on the axis of symmetry. So the x value is the axis of symmetry value, and then this just means plug it into the function and get the y value that goes with it. The y-intercept, as we've done many times before, means plug in 0 for x, and the roots or x-intercepts or zeros, we set the function equal to 0 and solve. So we're going to look at two examples with this and just kind of go through those properties. So in the first one, first we want to say the direction. So this is a positive, so that opens up. We're skipping, the width. We talked about that because that's a geometric topic and that's what we're talking about here. But basically, we're not going to answer that. The next question we're going to do is, what is the axis of symmetry? So that formula is x equals negative b over 2a. So in this case, that would be negative b would be negative 8 over 2 times a, so a is 2, which gives me 8 over 4, which is just 2. So the equation of the axis of symmetry is x equals 2. The next thing I want to find is the turning point or the vertex. So basically I'm just going to take this 2 and plug it into my equation. So I have 2 times 2 squared minus 8 times 2 plus 6. Be careful, you can just type that all in your calculator, but make sure you follow PEMDAS if you're doing it by hand. So this is 8 minus 16 plus 6. So that equals negative 2. So my turning point is the point 2, negative 2. My next thing I want to find is the y-intercept. Now, nicely, you can just identify the y-intercept because if you plug 0 into any function where there's an x in every term but 1, right, your last number, your c, your number by itself, is going to be that y-intercept. So if I plug it in, right, these two will just be 0 and it's just 6. okay? Setting this up to solve for the roots, which is something very similar to what we did in the last lesson, right? We started to talk about that. Just move this up. Right, so we're going to set the function equal to 0 this time. So 2x squared minus 8x plus 6 equals 0. Nicely, we have a GCF we can take out. So this is x squared minus 4x plus 3 equals 0. This is x minus 3, x minus 1. The 2 is nothing, so we just have roots of 3 and 1. And if I just do a quick check, do you see how the axis of symmetry is in between those roots directly? And that's what I expect if that graph is symmetric. So looking at the next one, this one opens down because it's negative x squared. The axis of symmetry, the line that cuts it in half, is negative b, so negative 6 over 2 times negative 1. So this one is actually going to be positive 6 over negative 2, so that's negative 3. So x equals negative 3. To find the turning point, which is C, I plug in that negative 3 to the equation. And that's going to give me 16 here. If you're doing it by hand, just make sure you don't cancel these two negative signs. You want to make that a positive 9 first with PEMDAS, just a side note there. So my turning point is negative 316. My y-intercept using that rule, right, from last time, right, that's just going to be the number by itself, so that's 7, okay? And then solving to find the roots or the x-intercepts, we set it equal to 0. And we factor again. Remember, I want to have that lead coefficient 1, which is why I took out the negative 1. So I get roots at negative 7 and positive 1. Remember, canceling out this just as I did over here because it's just negative 1 equals 0. So quick check 2, right? My axis of symmetry is directly between those two roots. Negative 3 is directly between negative 7 and 1, which makes sense for everything to fit together.